Okay, so now in this particular video, I'm going to be going over how to calculate the instantaneous rate of change in a very brief method. It's more of something called a graphing method. And in a later video, I'll be going over the three technical ways of calculating the instantaneous rate of change, which will give you a good approximation in terms of like an estimate. And then the final way would be using the difference quotient, which gives you the exact instantaneous rate of change at that particular point. So we just need to clarify that instantaneous rate of change is how something is changing or a variable is changing at that particular instant on a graph or on a function with respect to with respect to another variable at that particular instant. So we know from the slope of an equation, it's m equals del y2 minus y1 over x2 minus x1. So if there is only one point, the difference, so let's say, let me just draw this quickly. Let's say we have some sort of function looking like this. If I want to find the instantaneous rate of change at that one point, okay, what happens is there is no difference in x. So actually, let me just quickly redo that. Here. So let's draw like this. So let's say this is your line, okay? And that's the line crossing that one point. So this line represents that slope at that particular point. So what happens is there isn't another point. So in this case, the denominator x2 minus x1, this is basically becomes 0. And as we know, we can't really divide anything by 0. It would give us undefined. 0 can't go into any number per se. When we come to calculate any value, integer, decimal, and we divide it by 0, we get undefined. So this gives us an undefined state because there isn't another point. But if we can imagine that this is on a grid, okay? So let's say we're on a grid line graphing paper, and we have this graph. It's done fine. You know, we've plotted the right points. We have key points on the function, and we draw this line that represents the slope, if it could occur, on that one point. So if we look at this slope here represents the instantaneous rate of change at that particular point because it's only hitting the graph at that one point. And the this line is called the tangent to the curve. So it's not a secant, it's not passing through 2 points, it's only crossing through 1 point. So we call this the tangent to the curve. So I'll just write that down here. This is we call this the tangent to the curve. Tangent line to the curve to the function. That's a tangent line to the curve or to the function at that particular point. So it's going to be really hard to do this calculation because we end up with 0 in the denominator. But if we have it on grid line paper, on graphing paper, and we draw this line, you know, as best as possible. So we look at it, we eye it, we make sure that the line is exactly touching that point. This line represents the slope of the tangent, and the slope along this line is constant. It's not changing. So if you look here, this slope does not change. It's always consistent on that line. So let me just get my different color. So this slope here represents the slope of a line, and that we know the slope of a line is constant. So in this case, if I can draw that line with good approximation. It's a good graph on graphing paper. All I really need to do is take 2 points along that line. Any 2 points, I wouldn't say they're exact. They would be accurate enough if the graph is drawn according to scale, or it's drawn in a way that is that's a neatly drawn graph. If you take the slope across those 2 points along that line, that would give you a good approximation of the slope of the tangent, and which would give you the instantaneous rate of change. We call this the so instantaneous rate of change. We call this the IRC, or it's more like an acronym. IRC is the instantaneous rate of change. So I'll just quickly write that down here. So that's your IRC. So really, you just find any 2 points along that line. So let's draw another quick graph. Let's say we have something like this. It's a parabola. We take, we want to find the slope. We want to find the instantaneous rate of change here. Let's say when x is 2. Let's say this is meters. And this is hours. Or let's say it's centimeter cubed. Here on the y. So we want to find the instantaneous rate of change at 2 meters. So that's meters. So we want to find the instantaneous rate of change at 2 meters. And what we're going to do is we're going to quickly draw the slope of the tangent. Just change the color. Okay, there we go. So we're going to make sure that that line passes through 1 point. And then what happens here is this line now represents the slope of the tangent, M tangent. So now I could just take 2 points along that line, any 2 points that are valid. So one of them would be, let's say, an x-intercept, and the other one would be the y-intercept. If I can accurately determine x and y-intercept, or as accurate as possible from the graph, and take the slope across those 2 points, that will give me a good approximation of the instantaneous rate of change, or how this case, volume is changing with respect to distance, or could be distance, or could be separation distance, etc. So let's say we had the y-intercept here. Let's say it's 0, -5, and the x-intercept here is 7, 0. So now I can take the slope of the tangent, calculate that from that line, from the tangent line, and same concept, so change in y with respect to the change in x. Change in y, you have -5. We can start with the far right here. So you have 0 minus 5 over 7 minus 0. That would give you 5 over 7. So the instantaneous rate of change at x equals 2, in this case at 2 meters, is 5 centimeter cubed per 7 meters. We can get the decimal value as well if needed. You can calculate this in terms of a decimal. So usually word problems we calculate in terms of a decimal, but at times you need to keep things in exact form or exact value. Okay, so that's just a brief way of calculating the instantaneous rate of change of a function graphically. And in a later video, I'll go over the 3 different methods to calculate the instantaneous rate of change using an approximation method two approximation methods, and one of them would be the difference quotient, which would give you the exact value for the instantaneous rate of change. And yeah, so this will give you some introductory preparation for a pre-calculus lesson, for any pre-calculus course or getting into calculus 1, because this all touches the base around rates of change, why they're important, why we see them in everyday society, and how they play an important role in the function of any society these days, any modern day society around the world. So if you like this video, please, thanks a lot for visiting and for your time. Please subscribe and leave any comments below if you have any particular questions. I'll be posting more and more videos on this channel as they move along in 2020. I hope that 2020 is going to be a great year for all of you. Happy New Year, and take care. Thank you.